Module 18, Lab 2, Task 1, compare and analyze IoT traffic using Wireshark. All right, to install the MQTT broker on the Server 2019 machine, we're going to log in and navigate to the Z drive. Module 18, BevyWise IoT Simulator, and double-click on the BevyWise MQTT route win64.exe file. All right, we're going to accept the agreement and click Next. The Select Destination Location page appears. Without making any changes to the default installation location, click Next. In the next window, click Install to complete the installation. All right, the installation completes. Click on Finish. Ensure that the Launch BevyWise Route 64 is checked. The MQTT route will execute and the command prompt will appear. You'll see the TCP port using 1883. All right, we've installed the MQTT broker successfully. We're going to leave the BevyWise MQTT running. To create IoT devices, we must install the IoT simulator on the client machine. So click on the Server 2022 machine and log in if you're not already logged in. Navigate to the Z drive. Module 18, BevyWise IoT Simulator, and double-click the 64.exe file. All right, the setup wizard appears. Accept the license agreement and click Next. Keeping the default destination unchanged, click Next. The Ready to Install screen appears. Click Install. All right, click Finish to complete the installation. All right, BevyWise IoT Simulator has been installed successfully. To launch the simulator, you're going to navigate to the C drive, BevyWise IoT Simulator, bin file, and double-click on the run simulator.bat. Upon double-clicking, the file opens in the command prompt. If a how do you want to open this appears, select Microsoft Edge and click OK. It'll open a URL for 127.0.0.1, port 9000. All right, the web interface of the IoT simulator opens in the Edge browser. In the IoT simulator, you can view the default network named Healthcare and several devices. All right, next, we'll create a virtual IoT network and virtual IoT devices. Click on the menu icon and select the plus new network option. The Create New Network pop-up appears. We're going to type any name, in this case, CEH_finance_network. And click Create. In the next screen, we'll set up the simulator settings set the broker IP address as 10.10.1.19. And since we've installed the broker on the web server, the created network will interact with the server using MQTT Broker. Do not change default settings and click on Save. Select Yes and OK for a configuration save dialog. All right, this step completes the creation of the virtual IoT network. To add IoT devices to the created network, click on the Add Blank Device button. The Create New Device pop-up opens. Type the device name. Here we'll use temperature sensor. And click Save. Oops. The device ID, TS1. And leave the description blank. All right, the device will be added to the CEH Finance network. All right, to connect the network and the added devices to the server or broker, we're going to click on the Start Network red color circular icon in the right corner. When a connection is established between the network and the added devices and the web server or the MQTT broker, the red button turns into green. All right, next, switch to the CEH V12 Windows Server 2019 machine. Since the broker was left running, you can see a connection request from 10.10.1.22, and the device is TS1. All right, switch back to the Server 2022 machine. Next, we're going to create the subscribe command for the device temperature sensor. We're going to click the plus icon in the top right corner and select the subscribe to command option. The subscribe for command TS1 pop-up opens. Select on start under the subscribe on tab. Type high temp under the topic tab and select at least once. All right, click on Save. All right, scroll down the page. You can see the topic added under the subscribe to commands. Next, we're going to capture the traffic between the virtual IoT network and the MQTT broker to monitor the secure communication. Okay, minimize the Edge browser. Click on the Type to Search field. Type in Wireshark and select Wireshark from the list. The Wireshark application window appears. Select the Ethernet interface. Make sure you've selected the interface with the 10.10.1.22 IP address. If you get a software pop-up appearing, click Skip this version, and then click Start Wireshark by clicking the shark fin. All right, leave the IoT simulator running and switch to the Server 2019 machine. All right, minimize all opened applications and windows. Open the Chrome browser. And navigate to localhost 8080. All right, do not use Internet Explorer to open that URL. All right, as soon as you press enter, the MQTT route sign-in page appears. Keep the default credential unchanged and click on sign in. All right, navigate to the devices menu. You'll be able to see the connected device TS1 in the left pane. Now we're going to send the command to TS1 using the high temp topic. Go to the command section. Select the topic as high temp. Type alert for high temperature. And click on the send button. The alert pop-up appears. Click on OK. The message has been sent to the device using this topic. Now switch back to the Server 2022 machine. We've left the IoT simulator running in the web browser. To see the alert message maximize the the Edge, let's say Internet Explorer, and expand the arrow under the connected temperature sensor device log section. You can see the alert for high temp. To verify the communication, we've executed the Wireshark application. Switch to Wireshark. Type MQTT under the filter field and press enter. All right, select any publish message. In the packet details pane at the middle of the window, we're going to expand the transmission control protocol, MQ telemetry transport protocol, header and flag nodes. Under the MQ telemetry transport protocol nodes, you can observe details such as message length, topic, and message. Publish message can be used to obtain the message sent by the MQTT client to the broker. All right, select any publish release packet. And in the packet details pane at the middle of the window, expand transmission control, MQ telemetry transport control, and header and flags nodes. Under the MQ telemetry transport protocol nodes, you can observe details such as message length, message, and message identifier. Now scroll down and look for a publish complete packet. Click on it. In the packet details pane at the middle of the window, again, expand everything out. Under the MQ telemetry transport protocol nodes, you can see the message length and message identifier. Now scroll down and look for the publish received. Again, expand out the nodes in the transport layer window. And you can see things like message length and message identifier. All right, much the same way you can select ping request, ping response, and publish ACK packets and observe the details. All right, this concludes the demonstration of capturing and analyzing MQTT protocol packets. Here we analyze different processes involved in the communication between an MQTT client and an MQTT broker using Wireshark. Understanding these metrics as well as the workflow can help you in quickly identifying the MQTT related issues. Go ahead and close all open windows, and that completes our lab and demonstration.